Hi guys, happy to be here. So this presentation will be in English. So there will be slides, but not a lot of them. I don't like slides, so I would say that about 75% of this presentation will be about demo. We'll be doing something, we'll be building containers and so on. Guys, containers is something which we all love or use, or at least we should use, because this is the future, okay? For a lot of application, containers is the way to build them. Not for all of those, but for most of them. And still, for a lot of people, for a lot of companies, even though we speak about containers, about Kubernetes and so on, we don't use them so much. So in this presentation, what I want to do is to go from zero to hero. So for those people who might not know containers at all, might not use them at all. I want to build a container. I want to put it into a repository. I want to deploy it into the cloud. I want to manage it using a couple of different services in AWS. So quite a lot of stuff in 45 minutes. So probably I won't make it, okay? But at least we'll see how many things I will do. Okay, so a couple of the slides, especially at the beginning. So, containers are especially important when we are building applications using, microservices strategy. So we used to have, monolithical applications. Now we have got, we are breaking those into smaller parts, which we are calling microservices. And in short, there are two default ways how we build microservices currently: serverless, lambda, or containers. And this is the only way which makes sense, to be honest. So the cloud is just great to build it. We can easily build small components using those containers, or maybe the serverless. They are loosely coupled, and it's quite easy to build them and to deploy it to the cloud. So, okay, why containers? Containers are being used from startups to enterprise by everybody, or at least they should be used. We can build our application just faster with them. We can be sure that what we are building in our home, in our own data center, will work exactly the same in the cloud. So they are making everything easier. We can be in one cloud, and tomorrow we could go to another cloud. So it's just quite a good idea to build a lot of things using containers. So in AWS, every week there are hundreds of millions of containers being deployed. They are being deployed on EC2 servers. They are being deployed on different kinds of orchestrations engine, like ECS, like Kubernetes. It's up to you how you will manage those. But it's probably a good idea to have those. So just to make it easy, I want to do on this presentation, I want to go from the start, from the beginning. So what I want to do is just to do small 1-minute introduction to the Dockers. I won't go into the details because I know that some of you already know those things, so I don't want to be bored with this presentation. So just 1-minute introduction. So in the past, we had a physical server. We would deploy their application A, application B, application C, and this was not a perfect world because application A was stealing some kind of resources from application B, like CPU, like memory. They were sharing some kind of data, they were sharing some kind of libraries, and so on. So this was not perfect world. So after a while, we started using, virtualization. So we have got hypervisor, and now we have got guest operating system 1 to 3rd, and now on top of it, we are deploying our application. And in short, this is how 90% of the clouds works. We go to the cloud, we spin up EC2 server, which is a guest OS, and on it, we deploy our application. And this has got a lot of benefits. We can be sure that application A is not sharing anything with application B. We know that application A won't steal any CPU or memory from application B, and so on. But also, this approach is quite heavy. Having, the VM, the virtual server, is quite heavy, so it's not so easy to spin up, VMs on the cloud. It's not like, 2 seconds and we are there. So another approach is with the containers. So again, we have got a server. This can be physical server. This can be, a VM. We have got another type of hypervisor. This is, of course, not hypervisor. Very often, we will have got a Docker daemon, and on top of it, we will have got our containers. Container with application A, container with application B, and so on. They are not, so the separation between those is quite good. Probably it's not as good as with VMs, so we still don't believe if that the separation here is as good as here, but it's quite good. So this is the way how we'll go with containers. We'll spin up a server and we'll just spin up, run Docker daemon, and we'll break it into smaller parts, which we'll call containers. So to have a container, to have a Docker container, we also need to have a Docker file. Docker file will be a way how we will specify that our application is living in a Docker container. So usually this will be one file with some kind of instruction, with information like based on which image this container is, based on which operating system, like in this example, based on Ubuntu, what kind of things should be installed on this container, and so on. Okay, so let's go and let's do a small demo, because this presentation will be mostly on the demo. Okay, so this is the AWS console. I will just make it a bit bigger because okay, now it will be better. So guys, so what I will do, I will spin up two services. One of them will be ECR. For those of you who don't know, ECR is a repository in AWS. So this is a place where we will store our Docker image. So first we'll build our Docker image, and then we'll push it to the ECR. ECR is like a Docker hub, but it's like a private repository only for our applications. So this is ECR, so this is the repository. I will now create our own private repository, so quickly get started, and I will call it Cloud Native. So this will be my repository. Now it's empty, there are no applications, there are no Dockers inside of it. So what I will want to do, I will want to, in 2 minutes, to push there my own application, which will be living in a Docker container. Okay, so let's leave it for a couple of seconds. And the second application, the second service which I want to run is Cloud9. Cloud9 is a service in which I will be coding my application. I don't need to use it, but just it makes everything easier for me. So for those of you who don't know, Cloud9 is just a way how we can build our application in a web browser without installing anything. So in short, on the left side, I have got some files. The most important is this folder. Do you see this, or should I make it bigger? Maybe like this. Okay, so I have got one folder, my Docker app. I have got some source files. The most important will be index.php. So this, as you can expect, this is my application. So I'm saying I'm having there, this is my Docker, yeah. So let's call it, let's add something, Cloud Native, Warsaw. Okay, and I will save it. And the second, or maybe the most important, is this part. Like I said, whenever we are playing with Docker containers, we need to have a Docker file. So this is information which will be used by the Docker daemon to know what kind of the container we are spinning up. So in this case, I will be using Ubuntu, quite old version, 12 something. I will be updating the Docker container, and I will be installing a couple of things, and the most important here will be Apache, because I want to spin up a Docker in which I will have got a PHP application. So I'm installing Apache, and I'm just copying those source folders to the place where where Apache is storing its files. So this is my file, this is my Docker file. I will save it, and now what I will want to do, I want to build this Docker container, this image, and I want to push it to my repository. So to do it, I will use standard Docker commands. So, because I never remember those, so again, this is this repository which we have created. So on the right corner, on the top, I have got view push commands. So here I have got those three standard commands, thanks to which I can build and push my image of my container to repository. The only one quite unique command is the first one, and the first one command is just AWS command, thanks to which Cloud9 will have got access to my repository. So if I will execute this, now I will have got information login success. So now I know that from Cloud9, I can talk with my repository, and I can push there my image of my container. Okay, so the second thing will be about building the container. So Docker build, and so this is a standard Docker command. I just need to execute it from the folder where I have got my Docker file. So I have got a Docker file, and now I will just execute this command. What it will do, it's nothing AWS specific, it's just downloading some dependencies, and it's just building my image of my container, and it's done. The second command will be about tagging. So the tagging is just a way how we will identify our container, and that's all. And the last command is about Docker push. So if I will execute this command, now from Cloud9, this image of my application will be pushed to the repository. So now if I will want to run this container in AWS, in Google, in my own laptop or wherever, I will be able to use the repository because I will be saying, dear EC2, dear server, run a container which is being stored in this repository. So now I have got information that everything went fine. So if I will refresh this part, I will see that now in my repository, I have got one image with the latest tag, and this one is image URI. So this is something which I will need to copy, because now when I will go to some kind of Kubernetes, to ECS, or to something else, I will need to provide this link, because this link has got information with where the image is being stored. Okay. So this was the first one about containers. So what now? On the left side, we had our application, and it had a Dockerfile file. We also have got now a Docker registry. We are using ECR. We don't need to use ECR. We can use Docker Hub if we want. We push our image there. And now what we want to run our Docker image. So we could do it in two ways. We could forget about Docker registry, and we could just use the Docker run command, or we will use this command, but will point to our image, which is being stored in the registry. Okay, so what now? What now we need to do? So it's easy to, let's imagine that this is a server. Maybe in the cloud, maybe outside of the cloud. And we have got two containers, container A and container B. Running containers on a single server is very, very easy. It's just, you execute the Docker run command, and now this container will be deployed on the server. Now, the second containers, it's just very, very easy. But the reality is that we don't play with single servers. Very often on the production in our companies, we don't have a single server. We have got a fleet of those. Maybe 3, maybe 100, maybe 1,000 of servers. And now there's a question, where should I put my container? Where is the space? How to scale it? How to manage? And so on. Because again, 2 containers, 3 servers, and very often, because it's so hard, we will have got another layer, which we'll call container orchestration. And we don't want to talk with servers itself. We want to talk with container orchestration engine. We want to talk with this part, and we want to say it, dear container orchestration engine, here is my container, run it somewhere. And it's about container orchestration engine, which will handle the deployment. There is a couple of different things which are being, responsible for. For example, capacity planning, auto-scaling, self-healing, and service discovery. And it's about the orchestration engine to do all of those stuff. So how to do it? In short, if we are going to the cloud, and especially to the AWS, there are 2 ways how we could do it. First thing is you can do everything by yourself. So you could spin up EC2 server, a server in the cloud, and you could install Kubernetes, maybe Mesos, maybe Docker Swarm. There's a couple of different engines which you could use. And the other way how we could do is we could use a managed service. And the reality is that for most of the people, they will go with the second approach because it might be cheaper and it will be just easier. So we don't want to do everything by ourselves. We will use a service which is doing this, what we're looking for. In AWS, currently there is 4 different ways to have this orchestration engines. So there is ECS, there is EKS, and there is Fargate. Three ways. ECR is the registry. So maybe let's talk first about ECS. So ECS is the container orchestration engine from AWS. So this is not Kubernetes. This is something which was created by AWS about, I would say, 5-8 years ago. So before Kubernetes was released as an open source project. And if I would need to compare this with Kubernetes, I would say that ECS is just simple, but it can only run on AWS. So some benefits and some limitation, I would say. So what we'll do now is we will spin up ECS cluster with servers, and we will deploy our container application, which we store in our registry. So let's go back to our console again. So this is our registry. And now let's go back to the console. Okay, so I'm going to the ECS because this is the container orchestration from AWS. And on the left side, I have got Amazon ECS clusters. And what I want to do now, I want to spin up a cluster of servers. Those will be servers on which I will be deploying my container applications. So currently, I don't have any clusters. I don't have any clusters on which I could deploy my container. So let's create a new cluster, which is using servers on Linux. And let's go to the next step. So let's call our cluster Cloud Native Cluster. And I've got option. If I want to use on-demand servers or Spot, who doesn't know what is Spot? Who knows what is Spot? Okay. So for those of you who don't know, Spot is just a cheaper version of the server. You will pay about 20-25% of the normal price. I will be talking more about this when we'll be talking about Kubernetes, so in about 20 minutes. So let's say we are going with standard on-demand servers. I will say that I need to have, let's say, this kind of type of server. So R3, maybe it's a bit too big. R4 2x large, and I want to have a cluster with 3 of those servers. I won't do anything else here. I will just skip those parts and just let's create it. Now what is happening in the background, AWS is spinning up 3 servers of the type which we have selected. It will take about 2-5 minutes, and in 2-5 minutes, I will be able to deploy on those servers my container application using ECS. So ECS itself is free. It doesn't cost anything. What we are paying for is those servers on which we will be deploying our containers. So let's leave it a couple of seconds, and because, like I said, it will take about 2-5 minutes. And let's go back to the ECS because we need to do something else. So we see that this is my cluster. It's being created, 2 more minutes. And in 2 minutes, I will want to deploy their container application. But what I need to have more is something which is being called a task definition. A task definition will be a way to say AWS, where is our application, in which repository, and how much CPU, how much memory I want to assign to it. So we need to do it first, and then, based on this task definition, I will be deploying my containers. So let's go to the task definition. I don't have anything now, and let's create a new task definition. The task definition which we'll be using EC2 servers, and let's call it, I will call it Cloud, maybe My Page Native. So this will be the name of my task definition. I won't describe all of the stuff because we don't have time. So now I can specify how much memory and how much CPU I want to assign to a specific container. So let's say I will assign 128 megabytes of memory, and I will assign 1 CPU for each of the container. And now what I need to do is I need to specify, okay, so where is my Docker image? So I will add container, and I will specify here, I'm pasting the link to my repository. So this is what I have, this is the place where I'm storing my Docker image. And I also need to provide the name. So let's say the name of my container will be Apache. And this is almost all. What I also need to do, I need to specify ports. Because on my container, I have got one application which is being exposed on port 80 because there's Apache. And I want this port to be exposed on, let's say, also on port 80 on my cluster to make it just easier. And that's all. Let's add it, and let's create this task definition. And that's all. So I have got currently my page native. So this is the definition of my container. It has got information: how much memory, how much CPU, what kind of ports am I using, and on which registry repository my image is being stored. So let's see if my cluster is already running. So everything is green. Let's view our cluster. Everything seems to be okay. If I would go now to EC2 service, so standard, EC2 servers, I would see that those 3 servers are the ones which were created by ECS. So ECS is creating servers which are just standard EC2 servers, which I'm able to see here. Okay, but I don't want to manage them from here, because I don't care about those. I want to talk with ECS, because the ECS is a way how I can interact with my cluster and I can deploy my Docker images. Okay, so now I'm on my cluster, and what I want to do, I want to deploy a Docker container. A Docker container, I will create something which is called a task. For those of you who know Kubernetes, a task would be something like a pod on Kubernetes. So I want to run a new task on EC2, which task definition I have got only one. So my page native. On which cluster? I have got only one cluster, so cloud native cluster. And how many of those? So let's say I want to have 3 or maybe 2 containers. And that will be all. So let's run it. So now what is being happened in the bottom, I see that 2 new Docker containers are being deployed. It will take about 5 seconds. So both of those are now in state running. So let's see if it's working actually. So let's open the first one. And here I will be able to see the link. So this is the link, the IP address of one of my Docker containers. If I will open it, I will see that this is the first one. So this is my Docker, Cloud Native Warsaw. Let's see also if the second one is working. So this is this. And this is the second. So we see that the color is a bit different. So this is the way how I made this image, that based on the IP address, also the color will change. So we see that this is actually a different Docker image. Okay, so what now? Usually what we would do now is, because this is what we have spin up, we have spin up 2 task definitions. They won't scale. There is no auto-healing. If I will kill those now, I'm selecting those 2 containers. If I will stop those, they won't be recreated, because we have created a task. And if we want to scale those containers, if we want them to be to auto-heal, to being auto-created, we need to create something which is called a service. So what I will do now is I will create a service. I will say maybe that I want to scale them based on some kind of memo or on some kind of metric, and I will also create a load balancer. So guys, first of all, let's create a load balancer. So let's go to the EC2. We need to create a load balancer like a standard load balancer with AWS. So again, I'm on the EC2 service on the load balancer tab. I have got currently only one load balancer, so this is WordPress load balancer. I don't care about this. I will create a new one. I will create application load balancer, and I will call it my native load balancer. Okay. I will be using port 80. I won't play with, with SSL, and I will need to specify the network. I believe this will be the correct one. I will say that I want to open port HTTP. And I will say that I want to forward the traffic, which will come to this load balancer, to containers. So I will call it containers. And I will also specify health check settings. So usually what the load balancer will do, it will check every 30 seconds if the containers are working. I don't have so much time, so I will change it for 10 seconds. And if 2 times in a row the container will say, yes, I'm alive, then the container will be treated as it's working. OK, let's go native. OK, let's go, and that's all. So now my load balancer is being created. So now what I will need to do, I will need to go back to my cluster, and I will create a new service. But I will need to do one more thing. Maybe you remember that when I was creating this task definition, I said that I want to map port 80 to port 80. Of course, if we have got 3 servers, so how many containers I will be able to have? Maximum 3, because 3 servers, 3 times port 80, no more. And I might have a situation that I want to have 20, 30 of those. So I will create one more task definition, but a bit better. So again, I will say EC2. Again, I will need to call it my page native 2. Again, let's say 100 megabytes, 128, and 1 vCPU. And again, 1 container. Again, let's call it Apache. Exactly the same. I want to specify the container is being exposed on port 80, but I won't specify the host port. Then it will be dynamic. And this is what I'm looking for. OK. And that's all. OK, so now I will go to my cluster, and now I won't spin up containers using the task tab. I will set up a service. So I will create a service. I will say that I want to use which task definition, my page native 2, because this is the second one with the dynamic port mapping. I want to call it my page www. How many tasks? Let's say I want to have 6 of those. I won't describe all of the features because we don't have time. Let's go to the next step. No service discovery, but I will specify that I want to connect my load balancer. Which load balancer? My native load LB. And I will just connect it to port 80. Containers native. And that's all. Next. This is one place more where we could specify that we want to scale our containers. If you are using containers, you need to think about 2 things. First of all, you might need to scale on the server layer because you might not have enough CPU or memory. But on the other hand, you also might need to scale on the containers level. So this is a place where we could say, OK, if my containers will be dying because of the utilization, just add new servers. OK, I will just skip this now, and I will just create a service. Again, it will take about 5-10 seconds if everything will work fine, if I didn't miss anything. OK. So let's go again back to my. So this is my service. It's saying now that there need to be, on the right corner, there need to be 6 containers. Currently, I don't have any of those. Now it's saying I have got 6 containers. If I will go to the task definition, to the task part, I will see that I have got 6 containers. Each of them, if I will open it, I would see that it's now using some dynamic port, not 80, but some different port. OK, so probably it's working. Let's see if my load balancer is working as well. So this was my load balancer. Let's click on the DNS. This is the link to my load balancer. Probably it won't work yet because the health check needs to be passed, so it usually takes about 20-30 seconds. But let's try. Let's see if the health check passed already. So this is container native. So currently my load balancer detects that there are 6 containers and they're being attached. So probably it will take, some of them. We will get back to this part in, let's say, in 2 minutes, okay? In 2 minutes, we'll see that it's working very well. One thing about this is one more thing. Very often what companies are doing, they are merging and they are building applications using 2 approaches, like I said at the beginning, containers and serverless. So very often we are building applications on containers when it makes sense, but in some parts using serverless like lambda might make more sense. It might be just faster and easier. So let's add, I think there's a problem. I might miss something, guys. Okay. So we'll skip this part. So yeah, probably it won't work. I don't know where I made a mistake, but there is a problem with the health checks. Okay, so let's leave it for now. Okay, so we have got 10 more minutes. So one more thing, guys. Fargate regarding ECS. So what I did now is I spin up a cluster which is using a servers, EC2 servers. Usually playing with servers is a boring stuff. If we have got a server, we need to manage it, we need to scale it, we need to pay for the full capacity. If we have got a server and we have got just a small container on it, we are going to pay for the whole server. So that's why there is something which is being called a Fargate in AWS, which is one of the more interesting stuff in AWS based on my experience. So Fargate is about spinning up Docker images, Docker containers, but without servers at all. So let's do this. So guys, let's create a new cluster, but now I don't want to play with servers, because it needs to, I would need to wait 5 minutes and so on. I want to have a cluster which will be using only networking. Let's go next step. I will call it no servers cluster, and let's create it. And that's all. So we didn't need to wait 5 minutes because there are no servers. So it's like this, and it's done. So currently we have got 2 clusters. Cloud native cluster, there are 3 servers, and there is no server clusters on which we don't have servers at all. So now what I will want to do, I will want to deploy here a container. So we used to have those 2 task definition, my page native and my page native 2. I won't be able to use it because those were being created with the configuration saying that they will be deployed on the servers. So I will create one more task definition with Fargate information. I will call it no server container. How much memory, how much CPU, and again, I will need to add this information about the repository. So just 1 second, because I missed my link. Okay. So I will call it again Apache, and this is again the link to my repository, and port 80. Let's add it, let's create it, and that's all. So let's go back to our no servers cluster, because now we don't have anything there. We don't have servers, we don't have containers, we're not paying for anything. And that's why this kind of serverless approach is also quite useful, because if you don't use it, you don't pay for anything. So I will now spin up one container. I will use a task tab, run new task. On Fargate, I will use no server container. How many of those? Maybe now 10 of those. Which VPC? I will use, let's say, this VPC. And that's all. Okay. So now what's being created, I see from here on the tab that 10 containers are being created. It will take about 30 seconds. It will take a bit more than with the previous approach because we don't have servers. So what AWS is doing now is looking for a server which is not being used by anybody. It will take this server, maybe it will be big, maybe it will be small, whatever, and on this server it will spin up this container which we have created. So usually it takes about 30 seconds. Let's see if it's working. It's still pending, so let's give it a couple of more seconds. If it will work if I have selected the right network. Okay, still pending. Okay, so let's give it 2 more minutes, and in the meantime I will open another service. Usually it's faster, so I'm today I have got quite a bit luck today. Just 1 second, guys. I think I have selected the wrong network, so let's do it one more time. 5 tasks. The default one. Okay. Okay. One more try, guys. So maybe one comment here. So currently Fargate is working only for ECS. So it's just an engine for ECS, thanks to which we can run container on ECS orchestration engine, but without the need of running a servers. This year it will also be available for the Kubernetes. So you will be able to run a Kubernetes engine without having a servers. So, okay, let's give it 1 more minute and let's go to the last part. So guys, the last part is about Kubernetes. So there's nothing, everybody knows Kubernetes. This is definitely the most popular, engine for running containers in the world. You can spin up a Kubernetes engine in your own, data center. It can be run on AWS. You can spin up it on AWS, on Google, on Azure, wherever you want. So the Kubernetes on AWS is being called EKS. So EKS is a managed Kubernetes. So from the last year, there's a service thanks to which you can spin up a managed Kubernetes engine on AWS. So for those of you who know, Kubernetes has got 2 layers. One is being called a control plane, and one is being called just nodes on which the containers will be run. So the managed control has got 2 parts, master and etcd, which is just the storage for master, which on this part everything is being saved. So this part, the top part, is being managed by AWS. So what we are going to do, we will spin up a managed control plane, which is being managed by AWS, and we'll also spin up servers on which we'll be deploying our Docker containers. So because it takes about 10-15 minutes on AWS to spin up a Kubernetes cluster, we don't have time, we have got just 5 minutes. So that's why I already did it just yesterday. So if I would go to the EKS, I would see that I have got a cluster which I have called event. So the easiest way to spin up a Kubernetes cluster on AWS is to use something which is called EKS CTL. So EKS CTL is just a CLI for Amazon EKS, which is making everything just very easy to spin up a Kubernetes cluster. Just one comment, like for example here, EKS CTL create cluster will spin up a Kubernetes cluster on AWS. So I did it yesterday. So now if I will use standard kubectl get nodes, I will be able to see that I have got a cluster which has got three nodes like my ECS, and now I will be able to run on those my Docker application. So I also prepared before a YAML file on which I have got my small application. This is almost the same application. It has got two parts, like deployment, which is using one container. So I will just replace it. And this is my image, which we have deployed just 40 minutes ago. And there is a service which will create a load balancer. So I will just save it, and I will just deploy it on my Kubernetes cluster. So I will use standard kubectl command, kubectl apply, and name of my YAML file. So now what it will be doing is I'm connecting with the control plane of my EKS. It will get this file, and it will create one container based on my image from my repository. It will create a standard service, a load balancer. This load balancer is a type of type load balancer. So in short, it will create AWS load balancer. If I will go now to EC2, and if I go to load balancers, I should be able to see that now I have got 3 load balancers. So this new one is being now created by the Kubernetes, and in about 1-2 minutes, if I will check this link, this DNS, I will be able to see my application. Probably it won't work yet, but let's see.
Tomek, how much time you need to finish?
1 minute.
1 minute, okay.
Yeah. So in about 1 minute, it would then work, and I would be able to see that the health checks are working, and I will be able to see
Tomek,
that.
just a quick comment. We can make this session a bit longer because we have a lunch right now. But please believe me, there are 200 people there, so you will not get your lunch anyhow. So if you don't mind and you want to sit like 2-3 minutes longer and ask some questions, we are fine with that, because they need to eat and then we can come there. So anyhow, okay? So for any of those, if you want to stay for a bit longer.
So guys, so if I will use, kubectl get pods, the pods is like I said before, like a task in ECS. I see that my pod is being created. It's there, it's running. So this is my Docker application. And let's see if it's working now. Or I'm completely unlucky today. So then my load balancer would be able to point to my Docker image. Okay, so the last thing, let's see if my Fargate is working. If not, this is really the worst presentation of my life.
Then we will open for questions.
Yes. No, it's not working. Oh my God. Okay. I made some mistakes. Sorry, guys. So, guys, just as the last part from my side. So, in short, in AWS there are 4 services which are making it easier to run Docker application. ECR, which is the Docker repository. There's ECS. There is a Kubernetes. If you want, to run a Kubernetes cluster, you like Kubernetes, you might run your application today in AWS, maybe tomorrow on your own data center. Then EKS is your way. If you want to run Docker application, but really quickly, then ECS will be the just easier way. It will just make everything faster, and probably it will be cheaper way, especially with the Fargate approach, which will make everything easier because you don't need to work and you don't need to think about servers at all. Cool.
And now we can open for questions. So I'm the guy with the mic. Yeah.
So how does Amazon manage the availability of Fargate instances? If, for example, the instances that you are running your application on is being used by the owner, so does the Amazon allocate it directly to some other, or you have to care about?
Yeah, this is a really good question. So, two things. So first of all, with the Fargate, you don't have access to the server. So the first thing of everybody is that maybe AWS is just sharing the servers with other people. It's not happening. So when we find a server, EC2, it will be only used by you. Maybe you will split up 2 containers, so maybe we'll use the server for your 2 containers, but first of all, we won't share servers with anybody else. And the second thing, if you are deploying a Docker application with Fargate, and you are saying, I want to have 2, 3 replicas of this container, what we'll do, we will deploy it across multiple availability zones. So you don't need to do anything. It will be automatically deployed in at least 2 availability zones. So even if one server, one availability zones will fail, your application will still survive. Of course, if you deployed only one container, and the servers on which your application is running has got a bad day like me today, then you might have small downtime, but usually after about 2-3 minutes, your application is again running.
So it should also switch between different servers.
If you can, please use the mic, because
So the question was, will it switch between different servers and so on? Yes, that's the case. So if you have got only one container, because those are your needs, you don't need to have more of those. And we have got a bad luck, and your server is just dying because live. Then we will switch to this container to a different server, and after about 30 seconds, 1 minute, maybe 2 minutes, your application will be again living. Like before, exactly.
Another question? Yeah, go ahead.
How does the pricing of Fargate approach compares to the EC2?
It depends. It depends because with standard EC2 server, there's a server, and if you will spin up there a small container, you are paying for the whole server. If you would compare this situation with Fargate, there is a server which you don't see. If you will spin up this kind of Fargate, this container on the Fargate, this will be cheaper. But if you will, if you have got a server and you are using all the CPU memory, full utilization, and you would compare it to a similar situation, even though you don't see a server, Fargate will be more expensive, about 40%, something about this. But again, here you don't need to think about the servers. You don't need to patch them and so on. But yes, so if you have full utilization, then Fargate will be more expensive. If you don't have full utilization, then Fargate will be less expensive.
Anyone else?
I think I've got questions for both of you. So Michał, maybe you can answer also this question. I know. Where you see more clients are going? To Fargate, ECS, or EKS?
So this is
don't answer as a consultant. It depends.
No, this is a really good question, and it depends. No, so
now you have to pay 400 zlotys.
It depends on what kind of the customer we are talking about. So if the company has got expertise in running Kubernetes because they were doing this for a long time and so on, they will go with EKS because they like it. They want to build a multi-cloud approach and so on. If the company wants to they want to use containers, but they want to do it quickly, faster than in the past. They don't want to think about the servers and so on. They will, want to use ECS, maybe Fargate, maybe Lambda at all. So there's no one answer. There's, everybody wants to make their life easier. So if you have got expertise in Kubernetes, EKS probably will be your choice because, why to play with another maybe orchestration engine. But, if you don't have expertise, learning Kubernetes is not like, you will spend 1 day and you are, expert in Kubernetes. It's not like this. This is a powerful engine, but you will need to spend the time. If you don't have this time, you will want to look for a, easier solution, and ECS and Fargate will be just those solutions.